Okay, 3, 2, 1, it's jam.
What's up, science fam? Sometimes you want to know more about someone, and the easiest way to know more about people is to ask them about themselves. Most people will tell you their life story pretty readily. They're going to talk about their childhood, their babyhood, what their parents are like, who their crush is, unless it's you. But sometimes they don't really want to share, and that's okay. You gotta respect that. In the case, however, of inanimate objects, like say the planet Earth, they can't talk, they can't speak. And in order to find out the life story of Earth, you'll have to look at the clues in the details that science leaves behind. In this session, we're gonna get to know Earth inside and out. My name is Sir Ramon, and this is Science with Sir Ramon. Let's get right into it. So, Earth has layers, but how did they form in the first place? So Earth's layers form through a very complex process that is related to the life of Earth itself. So let's take a closer look at how Earth got its layers. So in this session, again, we're going to review our objectives. We have to explain Earth's history, differentiate the layers, model the layers based on their properties, and explain how rock, soil, and other things can be used to figure out more stuff about the Earth, especially based on how they layer themselves. Right. So let's start at the beginning. How did the Earth form? How did Earth start out? So Earth formed along with all the other planets. It's just one sibling out of one whole solar system family. So this is explained by the Nebular Hypothesis. It's the most popular hypothesis on how the solar system formed. So step one, you start with a nebula. It's basically a cloud of dust and gas. Step two, you make that cloud of dust and gas collapse into a very condensed space using a gravitational collapse. Just sprinkle in some gravity or some shockwaves from a supernova. Step 3, that nebula will turn into a protoplanetary disk. Just imagine a top spinning around, a fidget spinner. But instead of, a fidget spinner, it's interstellar dust and gas. So it swirls up into a big central ball that forms into the sun and a disk of debris. Step 4, you mix it until there's protoplanet clumps. So the protoplanets are the pre-planet forms, the planets. So they form due to accretion, basically when things bump into each other and clump up into bigger clumps. So Earth was starting to form very close to the Sun, so only dense materials could stay solid near the Sun. Finally, step 5, let the protoplanet clumps grow into real planets and tiny moons. Earth's moon is theorized to have formed by an impact with early Earth that made a chunk fly off and turn into a satellite. So that's how the Earth and the moon formed. But young Earth was a hot mess. There's lots of heat, lots of dense materials, and that turned into the layers. How did that happen? So first we have a magma ocean Earth. So let's get rid of my face. Where did all this heat come from? So there's two main heat sources. There's heat source number 1, high velocity impact of planetesimals. So things collided with early Earth, and that impact added energy in the form of heat. So basically, Earth was slapped, so that it turned hotter. That's heat source number 1. Heat source number 2, on the other hand, is the radioactive decay of heavy elements. What does that mean? So it means that your radioactive elements break up into smaller pieces, and when they break up into smaller pieces, they release radiation or energy. So when they release that energy or radiation, it turns into heat. Next, everything got melted by the heat. So where do the more dense materials go? Where do the less dense ones go? So if everything melted, what happens is what we call differentiation. Due to the concept of buoyancy, less dense things float and more dense things sink. So what happens is that the less dense materials float to the surface of the Earth, while the more dense materials go to the center of the Earth. So what caused the layers in the end? How did Earth's layers settle down into where they are? It's a combination of two things. So let's just clarify that differentiation caused the layers by composition. So your crust, mantle, and core formed due to differentiation. On the other hand, heat caused the layers by physical properties. The solids are solid because there's not much heat, while the liquids are liquid because there's lots of heat and not much pressure. So let's take a look at the Earth's layers one at a time. Let's look at the properties of each layer. The crust is the outermost layer by composition. There's the continental and the oceanic crust. Continental crust is mostly made out of granite or granitic rock, so it's not that dense. Oceanic crust, on the other hand, is made mostly of basalt rock, which is more dense than granitic rock. This is an important concept later when we take up plate tectonics. Next, we have to look at the elements in the crust. When we look at the elements of the crust, we'll find that the most abundant element is oxygen. It's found in many compounds. Even in soil and rocks, there's oxygen. But it's not the same oxygen that we can breathe in. That's oxygen gas. Oxygen forms compounds with other things like silicon and aluminium, or aluminum, whether British or American, however you want to pronounce it. So the lithosphere is the outermost layer by physical properties. It's rock solid layer. It's the crust and the upper mantle, which is also relatively solid. What's underneath the crust though? What's under the surface? We have the mantle. It's the second layer by composition, and it's rich in iron and magnesium, so it's more metallic. In the upper parts of the mantle, we have the asthenosphere. It's plastic, meaning it's technically solid, but over geological time, or a time scale that spans much, much more than our lifetimes, over thousands of years, it can technically flow. So it's solid, but flowing. As you can see in this image, there's currents. So if it flows, can stuff float on it? The answer is yes. And in fact, there's a term for it. There's isostasy. It's how much the crust or the lithosphere floats on top of the asthenosphere. Again, isostasy, how much it floats above the asthenosphere. So you can see actually in this diagram, let's hide my face, when there's a mountain on top of the asthenosphere, it tends to bend the asthenosphere, making a thick crust. When that mountain starts to get eroded or broken down, then the mantle rebounds and the crust turns relatively the same thickness as the rest of the crust. Take note of that. Under that, there's the lower mantle, which is solid. So it's not plastic, it's just straight up rigid, solid. There's so much pressure, it's mostly rigid, solid again. In the center of the Earth, or the heart of the Earth, we have the core. It's the innermost layer by composition. It's mostly iron and nickel forming an alloy. So it's so mixed together, it's an alloy now. Now the outer core is liquid because there's not enough pressure to make it solid. The inner core has tons of pressure, so it's solid now. Now the outer core spins around the inner core, creating an electromagnetic field. So it's caused by the core, and it protects the Earth from most of the solar radiation from the sun. Without the electromagnetic field, we'd all be fried. Fun, right? So we'll take a breather and we'll continue in the next video because that's pretty heavy, and the next video is even heavier. I'll see you guys next time.
That is over.